Welcome to Train Signal. You're watching a lesson on user authentication. Now, I will tell you, in this course, there's a number of different lessons we've had that are related to network security. And although the word security doesn't appear in the title of this lesson, I'll tell you, user authentication plays a huge role in keeping things secure on your network. So let's go ahead and get started. All right, so now even though the lesson is called user authentication, we need to kind of have a breakdown here of what I like to call the 3 A's, authentication, authorization, and accounting. And make sure that we know the difference between these terms and understand not just the differences, but how they also can work together. So if we start off with that term authentication, we need to understand that this is nothing more than the process of identifying a user or computer. Okay, and that's it. The line is drawn right there. Authentication is just identifying the user or computer. That's it. From there, we can move into authorization, which is then the process of determining the level of access that that user or computer has to given resources or possibly different privileges. Okay, so you need to, before we even get into accounting, these two, authentication and authorization, you need to understand that they work together, but that there is a difference. Authentication is just the process of identifying, and authorization is then just the process of determining what that user or computer has access to and the level of access that it would be. Now, the third A is accounting, and this is the process of keeping a log of activity by that user or computer. And there are many different types of accounting that we can talk about in different areas of computer networking. But when it comes to what we're talking about here, it really has a lot to do with keeping track of when somebody has logged on to a network and how long they were there for, and things like that. Now, there's also another A, which is not included here, which is related to accounting, and it's something called auditing. And that's where we can get into much more detail as far as keeping track of what a user or computer is doing. But when it comes to the authentication aspect of things, authentication, authorization, and accounting all kind of work together. And I will tell you, there are 2 specific protocols which will cooperate with these 3 processes. Okay, and those 2 protocols are, first of all, the Remote Authentication Dial-In User Service, or RADIUS, and then there's the Terminal Access Controller Access Control System Plus, which is TACACS Plus. And so that's why I'm tying these 3 A's specifically together, because we have these 2 protocols that can do all 3 of these things all together in one system. Now, there are a few other somewhat subtle differences between the TACACS Plus and the RADIUS protocols, but one of the main differences that really stands out is that TACACS Plus relies on TCP connections, and you may recall from other lessons that we talked about TCP being a reliable transport layer protocol, whereas RADIUS uses UDP connections, which is a connectionless transport layer protocol. Okay, so that is one significant difference between the 2. So here in this diagram, I want to kind of illustrate how the RADIUS or TACACS Plus process works. And the idea here is, on the left-hand side, you'll see we have a bunch of remote clients. Okay, and although there's 3 of them there, I want you to picture that that's a representation of what could be thousands of remote clients who are away from the office. And in order for those clients to connect into the office, they are going to have to connect in via remote access servers, or we could say VPN servers would be more typical these days, which, by the way, a VPN server is a remote access server. So on the right-hand side of the internet cloud here, you'll see I have 3 remote access servers. And the reason is because we have these thousands of clients, and although we may typically think of it as connecting via one remote access server, maybe one is not enough. So we have multiple remote access servers, but we want all of them to act consistently. We want them to have a consistent set of rules surrounding these remote connections. So these remote access servers are actually, we could say Radius or TACX Plus. And I'll tell you what, let's just stick with Radius for the simplicity of just sticking with one. So we'll say that they are actually acting as Radius clients. Okay, so the three servers to the right of the Internet Cloud here are remote access servers, but they are then Radius clients. And what that means is they then will communicate with a centralized Radius server. Okay, so all the way over on the right, on the top, you'll see we have a Radius server. That Radius server is responsible for being a centralized repository of the rules, so it can make sure that all the remote access servers have to follow the same rules when it comes to remote access connectivity. But the other thing that the Radius server will do is it will then communicate with the last server I have listed on this diagram, which is all the way to the right on the bottom, which is a directory services server, or we could say in the case of Microsoft, an Active Directory domain controller. Okay, and that's how we are going to go ahead and authenticate that the user information is correct. In other words, when a user tries to log in remotely, they're going to have to give their credentials, and those credentials will be passed from the remote access servers, aka Radius clients, over to the Radius server, and then the Radius server will go ahead and communicate with the Active Directory domain controller to make sure that those are the correct credentials. And if they are, that information will be passed back to the remote access servers, who will go ahead and tell the clients, okay, you've been authenticated. So the idea here is that the Radius server is a central repository of keeping consistent remote access rules for all the different servers. And it also is a central point that all those servers can go through to authorize the clients who are attempting to connect. But one other thing that the Radius server would do in this scenario is if the settings have been enabled, it will also keep an account of the connections. As far as who is connecting, it also keeps track of like how much data is being transmitted back and forth and how long they were connected for. Now, if you're wondering why we're keeping track of the amount of data, this goes back to some of the old days, back when everything wasn't unlimited, back when you used to actually have an internet service provider, and that service provider would give you X number of either minutes of connectivity or X number of maybe bytes or kilobytes or megabytes, depending on how far back we're going, how much data you were allowed to transmit based upon how much you paid them every month. That's where the idea of some of this originally came from. Now we use it more for maybe some of our 802.1x environments, which I know we haven't talked about that yet. That comes later on in the lesson. But more of our enterprise level environments, if we need to keep track of users and how long they're connected for and how much data they're transmitting. So now moving along, let's talk about specific authentication protocols. And so here I want to talk to you about something called Kerberos. Kerberos is used as a secure authentication protocol. To be more specific, let me talk to you about some of the characteristics of Kerberos. Part of why it's considered to be a secure authentication protocol is that it uses a secret key to keep authentication information, aka your usernames and passwords, secure. Okay, I will tell you that in the old days, before we used Kerberos, there were plain text databases in some cases that were used to store usernames and passwords, which meant if somebody gained physical access to the directory services server, well, they could fairly easily get a hold of everybody's username and password. They can't do it quite as easy with Kerberos. I can tell you that Kerberos also uses something called a symmetric, and just to be clear here, I didn't say the word asymmetric. I said it uses a symmetric key encryption methodology. Okay, so what that means is it's typically used within a private network where key management can be handled easily. Now we're going to talk a little bit about symmetric versus asymmetric. That's why I gave the clarification a minute ago. We'll talk about the different type of encryption and what the benefits and the drawbacks are for each. Kerberos allows users to have what's called single sign-on. Single sign-on means that you basically sign on once. So, right, you get into the office first thing in the morning, you enter your username and password, and you are logged in. Now, when you go around the network accessing resources, you don't have to be prompted again and again and again for your credentials. You just get to access the resources based upon your original sign-on. That's what single sign-on means. One last piece of information about Kerberos that you should know is that it can also be used for something called mutual authentication. Now, mutual authentication is a process where the server doesn't just validate the client, but the client can also validate the server. All right, so that's another feature of Kerberos. Kerberos is one of the most commonly used authentication protocols in today's world, and that's why we're spending so much time on it here. Now, let's talk about a process called multi-factor authentication. Now, by definition, multi-factor authentication is the process of using more than one form of authentication to identify our user. But what does that actually mean? Well, there's 3 factors. So when we talk about multiple forms of authentication, we could say multiple factors of authentication. Kind of makes sense in the name. There are 3 different factors that we can use when it comes to authentication. We can go off of something that somebody knows, we can go off of something that they have, or it could be something that they are. So let's talk about what each of those mean. Starting with something that they know. When you log in and you use your username and password, that's something that you know, right? That's just information that you enter in. You know the password, so you key it in. Something someone has means that a user physically has something. An example might be a smart card. If somebody is going to have to be authenticated by using a smart card in a smart card reader, it means they physically have to have that card in order to get logged in. And when we want to talk about something that somebody is or something they are, it means that we're using something typically biometric, okay? A fingerprint scanner or a retina scanner, photo recognition, voice recognition. That's stuff that is part of your actual human makeup. It's something that you are. So these are the multiple factors that can be used. So although technically multi-factor means that you're using more than one, I will tell you that there is another term out there. Some people will refer to something as two-factor authentication. Well, two-factor just simply means that you're using 2 of the 3. Technically, that's still multi-factor. Some people will tell you, they'll argue that multi-factor means you're using all 3. So two-factor authentication, an example of this might be if you have a smart card that you have to insert into the smart card reader and you have to enter in a password. That means that you have to have the physical card and you have to know the password. Or we could say multi-factor could also be, let's say that you do a fingerprint scan, and then once it scans your fingerprint, it then prompts you for your password. A complete multi-factor, where we talk about all 3, might be an example of you have to have the smart card with you, you put it in the reader, it scans your fingerprint, and you have to know the password. Okay, I mean, you can get as creative with this as you want, but I want you to understand what the term multi-factor authentication means. Now, let's get into a little bit more of it's a little bit more advanced, something called PKI, which stands for Public Key Infrastructure. So what is PKI? Well, this is a term, a lot of people will hear this term, but what does it really mean? It describes a network which has been fully configured to use something called certificates and public key encryption. Now, certificates, we're not going to go into great detail on certificates, but it's a form of identification card that is used in computer networks. Okay, so all users and computers will have certificates that are used to identify themselves. And public key encryption is a process that I am actually going to go through here. And I will tell you, I consider this to be PKI 101, or really we could, instead of PKI, we're not necessarily going through the entire infrastructure because we're not going to talk about certificates, but public key encryption 101. Okay, and this is another example of something that I've done this a few times throughout the course. You kind of have to let me give you each piece individually, and then in the end, it should all come together. Now, in order to learn about public key encryption, we have to first talk about something called cryptography. Cryptography is the process of applying an algorithm, okay, or a formula, we could say, to clear text, right? So you just have your plain old text that we all can read, and when you apply that algorithm to it, it gets converted into something called ciphertext. So an example that I have here is that we could have an algorithm that says, go up X letters. Now there's another term here that you need to be familiar with, and that is something called a key. Okay, so typically there'll be an algorithm and a key in cryptography. The algorithm is go up X letters. The key is X. Okay, so we fill the key, or really I should say we replace the letter X with our key. So if we say that our key, or X, is 2, then the algorithm says go up 2 letters. So the name train signal in plain text or clear text would be converted into, I'm not even going to try to pronounce it, but it's VTCKPUKIPCN. That's the ciphertext that represents train signal. And I did that as simple as taking the T in train signal and you go up 2 letters, right? So you go T, U, V. That's how I got to that V. The R in train signal, you go up 2 letters and you go, let's see, R, S, T. That's why you got a T there. Okay, so that is how that formula works. Whereas if X is 5, right, so we're using the same algorithm. The algorithm is go up X number of letters, but now the key is 5. Well, then train signal becomes YWFNSXNLSFQ. And again, we're using the same process where we just go up X number of letters. Now, why am I telling you all this? Well, it's because I want you to see how this relates to a term called key, right? We're going to talk about using keys when it comes to cryptography and encryption. Now, when we use symmetric key encryption, the same key is used to encrypt as the one that is used to decrypt. Okay, so if I go back a second, you'll notice that this example that I have here would be one that is kind of like using a symmetric key. In other words, if the algorithm is to go up X letters and the key is 2, then the way you decrypt it is just to go down 2 letters. Okay, the key is still 2. You just reverse the algorithm and use the same key. So that's what we mean by symmetric key encryption. The same key is used to encrypt is used to decrypt. This would mean that there'd have to be a key for every unique communication, which means it's also only good for use in a small and very secure environment. So let me give you an example. Let's say we had an environment that was as simple as there's 100 users. That's not a very big environment, right? 100 users. Well, each of those 100 users would have to have 99 keys to have a unique key to communicate with each of the other 99 users on the network, right? So you got user number 1 would need 99 keys, one for communication with each of the other 99 users on the network. Then you go to user number 2, and you say, all right, well, he's going to have not just the 1 key to go back to user 1, but then 98 more keys to communicate with each of the 98 remaining people. Then you go to user number 3, it's going to need the keys we already had for the first 2 users, but then 97 more keys. So you want to figure out how many keys you need, and there is a formula, and we're not going to go into a whole math lesson here, but the bottom line is you'd need 99 plus 98 plus 97 plus 96 plus 95, all the way down till you get to, plus 1 more key, right? So you do the math, that's a lot of keys. I mean, it's thousands. So that's why we're saying it's only good for use in a very small environment, and it also needs to be in a secure environment, because if you're going to use one of these keys over an unsecure network, there needs to be a way to have that key shared between the 2 users, right? So they have to both know what the secret key is, right? They have to both have that secret decoder ring in order to know what that key is. So what we'll do is very often in order to transmit that symmetric key, we'll have to use an asymmetric key for that secure exchange. So what does that mean? Well, let's talk about asymmetric key encryption. With asymmetric key encryption, something called key pairs are used to encrypt and decrypt the data. Okay, so you have a pair of keys. One key in the pair is used to encrypt, whereas the other key, the matching paired key, will then be the one that is used to decrypt the data. Key exchange and storage is simplified, which means it is good for use in a large, unsecure environment. And guess what? The most common form of asymmetric encryption is known as public key encryption, which is exactly what we are talking about here. That's how this is all coming together. Now I want to kind of go a step further and explain what I mean by key exchange and storage being simplified and that it's good for use in a large environment. So let's start off by just understanding that for every user in your environment, each user is going to have a pair of keys. Okay, so and again, please take this one step at a time. Just grasp each thing that I'm saying. Don't try to put it all together till the end. So right now we have these users in our network and they each have these two keys. One of the keys that each user has is what's known as the private key. That key, for the sake of trying to understand it, we'll say is in the pocket of each individual user. There is a matching paired key to each of those private keys that every user has, and that's what's known as the public key. Now, the public key, just as it sounds, is public. It's accessible to everybody. So picture that all of the public keys that each of our users have, it's labeled, right? It's got the user's name on it, but it's stored out in, we'll just say, a box. Some public, picture a box on the wall, a box of keys on the wall, and everybody has access to that box. All right, so for right now, every user has a pair of keys. One's private, one's public. The private one is only accessible to the individual user. The public key is accessible to everybody. So let's go to an example. Let's go, really, I should say, back to our example of the 100 users, right? Because we already determined that if there were symmetric key encryption taking place, well, then we're going to have thousands of keys. In the case of 100 users using public key encryption, since there's just a pair of keys, there's only a grand total of 200 keys. 100 of the 200 keys would be private and only accessible to the individual users, and the other 100 keys would be public and would be accessible to everyone. Those are the 100 that would be stored out in that box somewhere. So what that means is each user has access to a grand total of 101 keys. The 100 keys that are in that public box, and then the one private key that's in their pocket. All right, so again, hopefully you're still with me, because this is just piece by piece here. Now I'm going to explain to you how we actually use these keys for secure transmission. And I will tell you that there's two types of secure transmission. Okay, so in this example I have here, John has some data, and he wants to send it securely to Mary, meaning he doesn't want anyone else to be able to read the data besides Mary. So what John will do is he will take the data, right? He's got just this raw plain text data, and he will encrypt it with Mary's public key. So he will go to that public box of keys, grab Mary's key, right? The Mary's public key to be more specific, and he'll encrypt the data with that key. Now here's the deal. Anytime data is encrypted with any key, doesn't matter which one of the 200 keys, for example, that we have, anytime that data is encrypted, the only way it can be decrypted or read or brought back to plain or clear text is by using the matching paired key. So if he encrypts it with Mary's public key, right, so he takes that key and encrypts it, takes that encrypted data and sends it over to Mary, what key can then be used to decrypt it? The answer is Mary's private key. Even that same public key that was originally used to encrypt cannot be used to decrypt. You have to switch now to the private key. So Mary will then take her private key and decrypt the data so that she can read it. So you see how that's secure, right? John sent data over to Mary, and only Mary could read it, because the only key that could decrypt the data was her private key, and only Mary had access to it. Now, let's talk about the other use for public key encryption. And that is, what if John wants to send what's called authenticated data to Mary? Meaning, it's not so much that he's concerned with if anyone reads the data. He wants Mary to be able to validate that it was sent from John and not from somebody pretending to be John. Somebody who's acting as an imposter who says, hey, Mary, my name is John, and I just sent you some data, and here you go. And then Mary goes, wow, why is John saying that to me? That doesn't sound like John. Yeah, let's make sure John sends data and Mary knows it's from John. what John is going to do is he's going to encrypt the data with his own private key. Okay, he's going to take his own private key, encrypt that data, send that data over to Mary. Now, when Mary gets it, she's only going to be able to access it by using what key? Right? You got to use the matching paired key. So what key would that be? If John encrypted with his own private key, Mary's going to have to take John's public key to decrypt the data. Because she decrypted it with John's public key, she knows that it had to have originally been encrypted with the matching paired key, which means it had to be encrypted with John's private key. If she goes and takes John's public key and tries to decrypt and it doesn't work, then she knows that whoever is saying that they're John isn't really John, because only John had access to John's private key, and only John's private key would have been used if it's able to be decrypted with John's public key. Now, I hope I didn't lose you there, okay? Because if I did, go back and listen again, because you really kind of have to understand the steps here. And that's how public key encryption works. And I will tell you that if you go back to symmetric key encryption when we were talking about it, and we were saying that a key exchange, so a symmetric key exchange over an unsecured network, is secured using public key or asymmetric key encryption, this is what we're talking about. If John and Mary wanted to have a private conversation and they were going to use symmetric key encryption for that private conversation, they would have to first transmit that symmetric key by encrypting it using an asymmetric key encryption process like public key encryption. An example of where this is done is SSL. That's just to give you one example of how it's done. SSL actually uses a symmetric key encryption for the actual encrypting of data, but the original validating and transmitting of that symmetric key is done using public key encryption. All right, so now that I've thoroughly confused you with public key encryption, and I hope I haven't, I'm making a joke there, and if I have, you may even want to, stop here and rewind the lesson until you get it. But let's just kind of go through a little bit more here when it comes to authentication and different authentication strategies. 802.1x is considered to be a secure network access control standard. It is really a set of protocols and requirements which include certificate services, right? So we go back to certificates, which we didn't really talk about because it's much more advanced than where we're at right now, so I don't want to lose the scope. And radius. Okay, so remember we talked about radius. So if you put certificate services and radius together, you have 802.1x. Now it's typically these days used for securing wireless network access, and you may recall from the wireless and wireless security lessons, we talked about 802.1x, but it is something that is capable of being used for helping to secure wired environments as well. So now the last thing I want to go over with you before we wrap this lesson up is just some of the remote access authentication protocols. And realistically, I can tell you that only the bottom two are used in today's environment. And I suppose technically there's a third one that is used, and that's the second one here, CHAP. But I want to kind of go through all of these, if nothing else, just so there's a little bit of a history. The very first one at the top, we have PAP, the Password Authentication Protocol. This is typically not used anymore because this is an absolutely just plain text, nothing to it, authentication protocol. It is not secure at all. If you want to move up into at least a medium level of security, you move up into something called CHAP, the Challenge Handshake Allocation Protocol. And again, you don't see it used too much, but it is still occasionally used when you are not in a Microsoft environment. Whereas when you are in a Microsoft environment, we have what's called MS-CHAP, which is the Microsoft Challenge Handshake Allocation Protocol, or MS-CHAP v2, which is really nothing more than a newer version of the Microsoft Challenge Handshake Allocation Protocol. So in a Microsoft environment, you are typically looking at MS-CHAP v2 if you want to get to, an even somewhat secure authentication environment. From there, if you want to get into a much higher level of security, we move into something called the Extensible Authentication Protocol, or EAP. And there are a lot of different versions of this extensible authentication protocol. And the reason why is because it's just what it sounds like. It's an extensible authentication protocol, meaning it has an API to allow other vendors to go ahead and add their own versions of extensibility to the authentication process. So an example of EAP being used in a Microsoft environment is if you want to force your remote access users to authenticate using smart cards, that has to be done using the extensible authentication protocol, because you have to have some kind of an API to allow for that extensibility of using a smart card reader, meaning going beyond just just your generic username and password. So those are your remote access authentication protocols. And so that brings us to the end of this lesson. And I do understand that it was a fairly long lesson. We covered quite a few things. So just to quickly review, we started off by talking about the 3 A's: authentication, authorization, and accounting. We talked about a couple of protocols that allow those to work together with one another, especially in an enterprise environment. We talked about some specific authentication protocols, both local and remote access. And then, of course, don't forget, we talked all about that little difficult part in the middle, where we talked all about cryptography and encryption. So make sure that you have a good firm grasp on symmetric versus asymmetric encryption, and especially on the asymmetric side as far as PKI, or more specifically, public key encryption, which is a component of PKI. So again, there's a lot that goes together to make up user authentication, but it's a very important component when it comes to the security of your network. So make sure you got a good grasp on this one, and I'll see you in the next lesson.